Hello, welcome to another video with me PMAC, for IGCSE Chemistry, Chapter 2, the experimental techniques. Okay, so in this chapter, I'm going to talk about the mixture and the compound. What is the mixture and what's the compounds? So we're going to see the difference between the mixture and the compound, and the measurements. So how could we measure in the experimental, and how many instruments that we use, the basic instruments for any parameters. And I'm going to talk about the purity and the criteria of the purity, and followed by the method of purifications. And I'm going to close with the end of the chapter questions that I brought from the IGCSE past paper. Okay? Right, let's start. The first slide is talking about the mixtures. Okay, the mixture is containing more than one substance, either elements and or compounds. For example, the seawater, the air, which is the air is a mixture of the oxygen gas, nitrogen, and neon, and another compound. For example, the carbon dioxide. Yeah. And the substances in the mixture have not undergone a chemical reaction, okay? It doesn't have any chemical reaction. All right, no chemical reaction. And it is possible to separate them provided there is a suitable difference in their physical properties, okay? We will separate them by the physical properties. For example, the solubility. Okay. For example, this picture. Okay. This is the elements of the sulfur, the yellow powder, the iron fillings at the top here, the gray powder, and the black powder here is the iron 2 sulfide. Okay, on the left hand, and on the right corner here, the bottom right, there's the mixture of the two elements. Okay, this is the mixture of the sulfur powder and the iron filling here. So how can we separate it? In this picture, the below one here, this is the magnetic bar. Okay, the magnetic bar. So the magnetic bar, it will separate the iron from the mixture. So that's mean one of the physical property that we can separate the mixture is the magnetic property. Okay. Property. And another physical property I'm going to talk later in how to separate the mixture. Okay. Compound. What's the compound? For example, if the mixture of the iron and sulfur is heated, which means it's get the energy, right? A chemical reaction occurs, and a new substance is formed we call iron sulfide, iron 2 sulfide. For the word equation is iron react with sulfur. Here on your left hand we call the reactants. Okay, and under heat condition, under heat reaction, so it's turned into the product which called the iron 2 sulfide. So here it's chemically changed. Okay, so that's mean the difference between the compound. One of the difference between the mixture and compound is the reaction. If the chemical reactions occur, that's the compound. But if it doesn't have any chemical reaction, it's the mixture. Okay? So the table here provide major differences between a mixture and a compound. Okay, let's start with the mixture. The mixture, it contains two or more substances, while the compound, it is a single substance. Okay, and the composition of the mixture can be varied, while the composition of the compound is always the same. And a while ago, I mentioned there is no chemical change takes place when the mixture is formed, but the compound, when the new substance is formed, it involves the chemical change. Okay, so no chemical change and chemical change. And let's talk about the properties. The property are those of the individual elements or the compound, but the property of the compound, which gonna be different to those of the components elements. Okay, and the components may be separated quite easily by the physical means or the physical properties, but the components of the compound can only be separated by one or more chemical reactions. So that means we need chemical reactions to separate the compound, right? Okay, this is the difference between the mixture and the compound. So the table here will summarize everything, the major differences between the mixture and the compound. Okay, let's start with the measurements. The first parameter is the time. We use the stopwatch or the stop clock, which are usually accurate to 1 or 2 decimal places to measure the time. This is the stopwatch we use to measure the time. The units of the time normally we used in the seconds or in minutes, although that the units may be used for extremely slow reactions, for example, the rust. Okay. So the conversion of the unit, basically 1 minute is equal to 60 seconds and 1 hour equals to 3,600 seconds. All right. Another parameters, the temperature. The temperature is measured using a thermometer, which can normally give the reading to the nearest degree. As well as the digital thermometers are available, which are more accurate. Okay, and the unit of the temperatures are degrees Celsius for this thermometer, but we can convert it to another units of the temperature as well. For example, the Kelvin. Okay, 273 Kelvin equals to 0 Celsius. So that's mean to change into Kelvin, it's gonna be the Celsius plus 273. Okay. All right. Another parameters, the mass. Okay. The mass is measured by using the digital balance. Okay, this is the picture of the digital balance. So here there are 1, 2, 3, 4, 5 or 4 digits, 4 decimals balance here. So which normally gives the reading to 2 decimal places or more if you need more accurate. Okay, we can use until up to 4 decimals. And the standard units of the mass is the kilograms. But in chemistry, grams are used most often, okay? So the conversion is the 1 kilogram equals to 1,000 grams, okay? Because kilo is the prefix, the kilo equals to 1,000 or 10 power of 3. Okay, that's why 1 kilogram equals to 100 grams. The next parameter, the volume of the liquids. The volume of the liquid, it can be determined using the several types of the apparatus. It's depending on the level of accuracy you need. For example, the pipettes. The pipettes are the most accurate way of the measuring a fixed volume of the liquid. Usually, 10 centimeters cube or 25 centimeters cube, but sometimes it's up to 50 centimeters cube of the pipette, or 100, yeah, let's say 100 centimeters cube of the pipette as well. So here, the volumetric pipette, or we have another kind of the pipette we call the graduated pipette. Okay, the volumetric pipette is fixed the volume. Okay, is fixed the volume of the liquid. It depends on the size of the pipette. Usually it's going to be 10, 25, 50, or 100 centimeters cube, respectively. And another apparatus is the burette. Okay, the burettes are the most accurate way of the measuring variable volume. This is the burette. So the burette can be varied, the measure of the volume, okay, between 0 and 50 centimeters cube. For example, we use burette in titration. Okay. Another parameters, the volume of gases. The volume of gases sometimes needs to be measured, and is done by collecting in a graduated measuring apparatus. Okay, so we use the gas syringe. The gas syringe is usually the apparatus used, and as well here the graduated cylinder. If we inverted the graduated cylinder in water, that can be also used, but that provided the gas that isn't water soluble. So that means it shouldn't soluble in water. It shouldn't be soluble in water. Okay. So if the gas happens to be heavier than air, it is colored, then the cylinder can be used upright. Okay. For example, the reaction mixture in the conical flask, which connected with the gas syringe. Here we can read the scale here. Okay. We can read out here the volume of the gas. Okay. All right. The next chapter, the next topic is the importance of the purity and assessing the purity. Let's talk about the importance of the purity. The pure substance consists of only one substance and contains nothing else. So that means it's only one substance. It's a pure substance, okay? Pure, only one. So to have a pure substance for food and drugs is very important, as impurity could be dangerous even in a small amount, okay? And the melting and the boiling point analysis is routinely used to assess the purity of the food and drugs. The melting point and the boiling point. MP and BP. Okay? How to assess the purity? The assessing purity, the pure substance melt and boil at the specific sharp temperatures. Okay? The melting and the boiling points data can be used to distinguish the pure substances from the mixture. We can compare the melting point and the boiling point with the data sheets. Okay, so if we've got an unknown pure substance, can be identified by comparing. It can be identified by comparing its melting point and the boiling point, and comparing to the data table, which is the existed data. Okay, and another thing is the mixture. Okay, the mixture melt over a range of temperature as they contain two or more substances. All right, this is the criteria of the purity, which mean the purity or the pure substance. It's supposedly to have only one substance. Okay, and contain nothing else. and they usually do the melting point and the boiling point analysis routinely to assess the purity of the substance. For example, in drug test and the food test. Okay, so if we have unknown pure substance, it can be identified by comparing its melting point and the boiling point. So we can compare the melting point and the boiling point that we measure from the unknown substance, and then we compare to the data table, the existed data table. So then we can distinguish, or we can identify the unknown pure substance. All right. This is how important of the purity and the assessing of the purity. Let's moving to the next chapter, next topic, the separating mixtures. Okay. The mixture consists of two, right, or more compound, right, or elements mixing, but no chemical reaction. Okay, this is the mixture. How can we separate the mixture? First, we're going to talk about separating the solid-liquid mixture. The solid-liquid mixture, the first method is the filtration. The filtration, it is used when the solid needs to be separated from the liquid. Okay, usually see the picture here. This is the apparatus to separate the solid-liquid mixture, the filtration kit. Here is the mixture is in bigger, and the glass rod. The glass rod will be let the water, or will let the solution to pass by the glass rod. Okay, through here, the funnel, which the funnels contain the filter paper. Okay, the filter paper will collect the residue. Okay, the residue from where? The residue from the mixture. Okay, the residue from the mixture. And the filtrate, or the solution that passed the filter paper, we call the filtrate, will be collected here. So we can collect the residue or the solid, and here is the liquid. The filtrate is the liquid. Okay, this is the filtration. Another one is decanting. The decanting, this technique is used quite often to separate an insoluble solid, okay, which has settled at the bottom of the flask from a liquid. And another one is centrifuging. Centrifuging is used when the solid particles are too small, okay, and they spread out, or which called disperse, throughout the liquid and remain in the suspension. Okay, after we centrifuge, we're gonna get this, the solid here, and the suspensions here. Okay, this is the solid. Or another method is evaporation. Okay, the evaporation, the solid has dissolved in the liquid. It cannot be separated by filtering or centrifuging. Instead, the solution can be heated so that the liquid will evaporate completely, and it leaves the solid behind. Okay, let's have a look here. This is the porcelain bowl. Was heated by Bunsen burner via the the steaming, or the steam, the water steam. So then the solution in the porcelain here will evaporate. The liquid, the water will evaporate and leaving the solid behind at the evaporating dish. Okay? Another thing is crystallization. The crystallization is a saturated solution. Is defined as one that contains as much solutes as can be dissolved at a particular temperature. And when the solution is saturated, the salt begins to crystallize. So let's have a look how to crystallize the solution. The step 1, here is the solvent and the impure solid. We stir to dissolve the solid. Okay. And in step 2, the solution is heated to evaporate most of the solvent. Okay. And 3, the hot solution is allowed to cool. Then the solid appear as a pure substance, as a pure crystal. Sorry. Because the solution here become saturated. Okay, become saturated. So then is allowed the crystal's growth. And in step 4, the cold solution is poured off to obtain the crystals. So the crystal may be dried by pressing them between the sheets of the filter paper. So then we can get the crystal. YSTA. Which call this method the crystallization. And here, the separation between the separation of the solution mixture. Okay, the simple distillation. If you want to obtain the solvent from the solution, then the process of distillation can be carried out. Okay, the water can be obtained from salt water. Okay, using this method, we can purify the water, the fresh water, or drinkable water, by using the distillation, the simple distillation. The solution is heated in the flask. Okay, this is the flask, the bottom round flask, until it's boiled, and the steam rises into the big condenser. Here, it's called condenser. The condenser will have the cooling system here. Here is the way to supply the cooling water in, and here to supply and here is the way for the cooling water to go out, and it's going to circulate. It's going to circulate in this condenser. It is made to lowering the temperature to condense the water, condense the vapor into the liquid. Okay, condense the steam to the liquid back into water, and then we're gonna get the salt left behind in the flask, and here we get the distilled water. Okay. The important things of the distillation, the important kits of the distillation is the flask, the bottom round flask, the condenser, and the water, the cooling system. Okay. And another mixture, or the liquids which are miscible. So if the miscible liquid are to be separated, then this can be done by the fractional distillation. What is the fractional distillation? The fractional distillation, it relies up on the liquids having the different boiling points. Okay, for the pure substance, which gonna have distinguished boiling and melting point. And here, the fractional distillation, it relies upon the liquids which having the different boiling point. For example, when an ethanol and water mixture is heated, the vapors of the ethanol can be and the water boil off at the different temperature. It can be condensed and collected separately. So the mixture of the water and the ethanol. Okay, the boiling point of the ethanol is going to be around 78 Celsius, and the water is around, let's say, 100 Celsius. Okay, so which means when we heated the liquid mixture, the H2O, the water, ethanol, so then the ethanol will be boiled, will be turned into the vapor faster than the water. So that's mean but both of the ethanol and water vapor will rising up. Okay. But here, the fractionating column with the short length of the glass rod inside, it will increases the surface area. Okay, so after that, the water will be boiling here, or maybe it's not gonna boil, but because we adjust the temperature around 85 Celsius. Okay, so then we're gonna get the ethanol vapor. Then it goes through the condenser, which condense the ethanol vapor to ethanol liquid. Okay, and collect, and the ethanol, the distillate here is the ethanol, can be collected here. Okay, and the water will be left behind here. This is the fractional distillation, and we can use the fractional distillation in oil refinery industry as well to separate by the boiling point. For example, the kerosene, the diesel engine, the diesel oil, and another kind of oil like or the naphtha or the asphalt. Okay. All right. Let's talk about the separating of the liquid mixture. The liquids which are immiscible. If two liquids are immiscible, so then they can be separated using the separating funnel. It looks like the carrots here, the separating funnel. The mixture is poured into the funnel and the layers are allowed to separate. Okay, we can separate by the layer. So the position between the layer depends on the rho or density. The greater rho will be at the bottom. Okay. And the lower density will be at above. Okay, so that's mean here the less density and here greater density. Okay. Another method is chromatography. What's the chromatography? The chromatography is used to separate two or more solids that are soluble in solvents. Okay, two or more solids that are soluble in solvents. The paper chromatography we use to separate the different color dyes in a sample of the black ink. Okay, let's have a look here. The chromatographic separation of the black ink. You spot the ink. Okay, a spot of ink is put onto a piece of the chromatography paper. This paper is then set in a suitable solvent. Okay, let's have a look here. The black ink was spot here. Okay, spot here, the starting point. And after that, we dip it in the solvent. Okay, and this is the way of the solvent soaks up the paper. Okay, the chromatography paper will be soaked up by the solvent, and it will lead the mixture of the black ink to separate. This is during the separation, during the solvent is soaking up the paper. And at the end of the separating, we've seen the dye P here at the bottom, and we've got another dye Q here, and we've got the dye R here. So now the three black ink, or the three mixing solution, can be separated. Okay, this is what we call this is called the chromatography. Okay, let's see here. As the solvents move up the paper, the dyes are carried with it and begin to separate. They separate because the substance have the different solubility in the solvents and are absorbed to the different degree by the chromatography paper. As a result, they are separated gradually as the solvents moves up the paper. The chromatogram in this figure, this is the chromatogram, shows how the ink contains three dyes, the P, Q, and R. Okay, the easiest soluble is gonna be faster, which means it's good soluble in the solvent. Okay, that's mean the solubility of three dyes are greater than Q and greater than P. Okay. The application of using the chromatograph, the paper chromatography, is if we want to know the sample, if the unknown sample, okay, we can use the paper chromatography to identify the which the substance is with a standard reference. Okay, so how can we do it? A sample of the unknown is placed along the pencil line. This is the pencil line, okay? And the other known elements we call the reference materials, okay? The reference material. are placed beside the sample along the sample line, along the same line as well, the pencil line. The chromatograms will show the composition of the mixture as the different colors, substance, or the components will spread apart as they will have the different solubility, so will travel at the different rates. Okay. A pure substance will only produce one spot on the chromatogram during the paper chromatography. Okay. And let's have a look in this diagram. This diagram shows the red, blue, and yellow are 3 pure substances. Okay. Whilst the same on the left is the mixture of all 3. If the mixture, if the 3 substances match with the standard reference here, so we can tell the composition of the mixture. We can identify by having the standard reference material. Okay. So the RF values. The RF values we use to identify the mixture components. Okay. The RF value, it stands for the retardation factors values, okay, or the RF values. It's used to identify the components of the mixture. The equation of the RF value is the distance moved by the compound, divided by the distance traveled by the solvents. Okay. The property of the RF value. The RF value of the particular compounds is always the same. So we can calculate the RF value. This allows the chemist to us to identify the unknown substance because it can be compared with the RF value of the known substance. Okay, under the same condition. If you set up the condition of the experiment to be the same as the standard substance with the known substance condition, so then we can compare the RF value by using the distance moved by the substance divided by the distance traveled by the solvents. Okay, so which means the RF value, it will be less than 1, right? The RF should be less than 1. This is the this is the chapter 2, okay? The chapter 2, we can distinguish the mixture, and chapter 2, mixture and compound, and what else? The method of the purification. Method, the criteria for pure substance, right? And the chromatography, the paper chromatography, and the RF value equals distance traveled substance divided by the distance traveled by the solvents. Okay, this is the RF value. All right. So let's start with the question from the past paper. The following techniques are used to separate the mixture. Okay, let's start with A. Where is A? Where's my pen? Okay, here. From the list, choose the most suitable technique to separate the following. A. The methane from the mixture of the gases methane and ethane. The methane and the ethane. The molecular weight is different. So we can use the fractional distillation, or we can use another one is diffusion by using the membrane. Okay, the permeable membrane, which is allow only the smaller molecules of the gas to pass through it. Okay, the B or F. The water from aqueous magnesium sulfate. The water from aqueous magnesium sulfate. So we need the water, right? So we can use the evaporation or the distillation, the simple distillation, right? Because we will get the water or the water vapor. The glycerine from a mixture of the amino acid glycine and lysine. Can use the chromatography. Okay, another thing, the iron fillings from the mixture of iron fillings and water. We can do the filtration. The zinc sulfate crystal from the aqueous zinc sulfate. Can use the evaporation, right? And then we're gonna obtain the and then we're gonna get the zinc crystal, the zinc sulfate crystal. And what else? The hexanes from the mixture of the liquid hexane and octane. We can do the fractional distillation because the boiling point of the hexane and the octane are different. Okay, different boiling point. All right. The next question. The esters can be used as the solvents in chromatography. The following shows a chromatogram of the plant acid. This is the baseline for the sample A. Okay, the sample A and the sample B. The cross represents the center of the spot. An ester was used as the solvents, and the chromatogram was sprayed with bromothymol blue. Question. Suggest why it was necessary to spray the chromatogram. Why do we need to spray the chromatogram? Because the sample, the mixture is colorless, right? And needs to spray the indicator solution. Indicator because the color will change by the different pH. Okay, let's have a look here. This is the bromothymol blue indicator. So this is the color, the useful range used between the 4 until if it's the basic solution. From 6.5, the useful range we use from 6.5 to 7.5. So we will see the difference of the pH value, right? If the pH is 6.5, the solution will be green yellow. If the solution if the pH of the solution is 7.5 or above 7, the solution will be turned to the brown, not the brown, the blue-green, right? The blue-green solution. So then we can separate or distinguish the sample. All right. Explain what is meant by the RF value of the sample. The RF value is the distance traveled of the substance by the distance traveled of the solvent. Okay. Calculate the RF values of the two samples and use the data in the table to identify the plant acids. Let's have a look at the sample 1. Okay, sample 1 and sample 2. So the RF value is RF equals to the distance of the substance, right? Divided by the distance of the solvent. So let's count the grids here. The RF of sample 1 equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, or 1.1. 1.1 divided by 5, right? Because here's 1 unit, 2 unit, 3 unit, 4 unit, and 5 unit. So the distance traveled by the solvent front is 5. So 1.1 divided by 5 equals to 0.22. Okay, let's have a look with, let's compare with the RF value. The sample 1, the RF value is 0.22. So which means it's the tartaric acid. Okay, and let's do sample 2. Here, the sample 2 is 23.1.2.3. The RF of the sample 2 equals to 2.3 divided by 5. So then it's equal to 0.46, right? Because 5 canceling here, it's gonna be 0.4, and 30 is gonna be 6. 0.46. The sample 2 is 0.26. 46, sorry. So that's mean it's the malic acid. Okay, this is how we use the RF value to find the unknown components compared with the database table of the RF value of the known substance. Okay, let's do the next question. The methanol CH3OH and the ethanol CH C2H5OH are immiscible or demiscible liquids, which diagram shows the apparatus that is used to obtain methanol from a mixture of ethanol and methanol. So what we see here, the different formula, right? So that means going to be different molecular weight. So the different molecular weight will be difference boiling point. Okay, so how can we separate by using the boiling point? We can do the distillation, right? The simple distillation. Okay, because it's using the different boiling point of using boiling point and used to separate the immiscible, right, mixture, the miscible liquid mixture. Okay, so the correct answer is B. Next, a mixture is separated using the apparatus shown. It has the funnel, has the filter paper, the mixture, and the filtrates. Okay, this is the filtrate. The filter paper and the solid here. What is the mixture? A, the aqueous copper chloride and copper. B, the aqueous copper chloride and sodium chloride. C, ethane and methane. And D, the ethanol and water. The ethanol and water are miscible. The ethane and methane, the gas mixture. Right? So here's gonna be the aqueous copper chloride and the copper. Because after we filtrate, the copper residue will be deposited on the filter paper, and then we're gonna get the filtrate is the copper chloride solution. Okay. The correct answer is A. All right. So these are the sample for how we do the IGCSE past paper for the chapter 2. So if you guys have any question or if you guys needs more clarify for each topic, you guys can just let me know by just left the comments below or typing or contact us via email or go to Facebook, we get pals. So I'm happy to do that. I'm happy to answer you guys. All right, all the best. So for today, I think that's gonna be it, and see you again for another video. Bye bye.